Let's talk about how blades are made for a moment. On the table here we have two blades. We have a rip blade and we have a cross blade. Right? Basically, blades have some pretty critical dimensions that are really important. We have the diameter, which for our saw is usually 305 to 315 millimeters. We have the arbor, which is the hole in the center, depending on whether you're American or not, and that's 30 millimeters for our saw. Right? We have a tooth count. So on something like this is going to be maybe a 24 tooth, and this is going to be about 100 tooth. So we're going to write 24, just guessing here, 100. We have a tooth grind. So in this case, this is going to be an ATB, and this one is a TCG. And we have a rake. So the rake is probably the most important one for a lot of these things. Our rip blade here is a very high rake. You can see that if I draw a line right out from the center of the blade, that this tooth here is on a fairly wide angle. Whereas if I draw a line out from the center of this one, that tooth is basically at 0. So we could say that this is a 0-degree rake, and this one, we're going to take a guess. Let's say that that's 18 degrees. All blades exist on a continuum. So if we draw a diagram, we have and this, and more rake, and less rake. Right? The more teeth you have, the less rake you can have. The more rake you have, the less teeth you have. So you can see here that low tooth count, high tooth count, low rake. So more rake, less teeth. This rip blade is somewhere down here. Cross-cutting, more teeth, less rake, it's up here. So if we draw a line, there's basically rip and cross. And all blades are going to exist somewhere along here. So you might have 100 teeth, 0 degrees up here, and you might have, 18 teeth, 24 degrees rake down here. And all blades are going to exist somewhere along that. And you can basically look at those two criteria to figure out where you need to be in order to find the right blade for the application. The only other criteria for blades that really matters is the tooth grind. Now, there's a lot of different tooth grinds for different applications, but in our shop, we'll typically only see 3 types. The first type is ATB, and that's 80, 85, 90% of the blades that you'll see both in Bunnings or in a shop. For most purposes, ATB is what you're going to see. There are some variations on ATB, but ATB looks like this. So you've got A, T, B, and that means it's an alternating tooth bevel. So that means that if you look at the face of each tooth kind of looks like this. And then the next tooth will look like that. And they alternate between the two. Different blades may alternate the angle of the face, that sort of thing, but a lot of the time you get ATB. If you try and do a grooved cut with an ATB, you'll end up with your groove looking like this, which is not very good for joinery. That's why we have FTG. We have one FTG blade. It's for our joinery. You might occasionally see them in rip blades because they're really hard wearing. FTG is a flat top grind, and every one of them just looks like that. And they're really good for joinery because they make nice flat grooves. The other one that you'll see is a TCG. TCG. This is the blade that we want you to use for aluminium because it's very hard wearing. TCGs, there's a couple of different variations of them, but a lot of the time what you'll see is you'll see a flat and then kind of a hexagonal top piece like that, alternating. And they're just good because of the hard wearing nature of them. So this is our aluminium blade. It's a high tooth count. It's a TCG blade. It's going to last a long time. This rip blade here is going to be very, very fast. The reason that it's going to be fast compared to the crosscut is the gullet. So if we talk about gullets for 1 second, gullets are a function of tooth count and rake. The less teeth you have, the more gullet space you have. More teeth you have, less space you have. The gullet is this space in here. That's the gullet. The gullet is where all the material goes when the tooth of the blade comes in and clears it out. So if you have a bigger gullet, you can remove more material. It means that the blade can go faster. Blade like this, I can't even get my pen in there, tiny gullet. So that's going to be a slow blade, that's going to be a fast blade. Picking the right blade for the application is important because not only does it make your work better, but it means that we distribute the wear across all our blades. We have to get them sharpened less, and you'll get a better result. For the most part though, a lot of the time, if you're doing something like a plywood cut, you're going to be, right in the center here. A general purpose blade, somewhere in the realm of 40-ish teeth, some fairly neutral 15-degree rake, and it's probably an ATB. That's your general purpose blade. That's what most of you will use most of the time. And then as you try and do specialty things, you'll go up and down this line.